Hello class, today what we're going to do is talk about how to prove that a mathematical statement is true. It's one thing to say, hey, these two angles are congruent. It's another thing to be able to prove it. How do you know? That's what we're going to talk about today. So here we go. First example. We're going to reflect a beam of light from a spotlight off a mirror lying flat on a stage as shown right here. And so we're going to do this. We're going to given that the measure of angle 1 equals the measure of angle 3, right here, measure of angle 1, measure of angle 3, we know that's true because we learned about it in science classes. We want to prove, though, that the measure of angle DBA is equal to the measure of angle EBC. So we want to prove that these two obtuse angles here are congruent. Okay, because one thing is to say, hey, those measures are the same, and then to prove it. How do you know those are the same? All right? So here's what we're going to do. We're going to use this format called a two-column proof. And it's called that because, you see, we have two columns. One column for statements, one column for reasons. So we're going to start off with what we know. Well, I know that the measure of angle 1 equals the measure of angle 3. That's what I know. Need a reason to back that up. How do you know that that is true? Well, I know that is true because I was given that information. I was given that this is 1, this is 2, and that they're 3, and that they have the same angle measures. That's what I was given. So that's what I know. All right, but this is angle 1 and angle 3. I want to talk about angle DBA, right? So let's take a look at this. Angle DBA, that's right here. And, well, let's see, that's angle 2 and angle 3 put together. So we can say that. We can say that we have the measure of angle 2 plus the measure of angle 3, and that's the measure of angle DBA. How can you say that this is true? Well, we've got that angle addition postulate that we talked about a while back that says so. Says that if I have two adjacent angles, I can add the measure of one to the measure of the other and get the measure of the whole thing. Right? So that's the angle addition postulate. Backs me up. Says that this is a true statement. So I'm good. Okay, what can I do with that? Well, let's see. I've got measure of angle 3 here. I've got measure of angle 1. Hey, measure of angle 1 equals the measure of angle 3. So I could swap those out. Since measure of angle DBA equals measure of angle 3 plus measure of angle 1, I can measure of angle 2 there. I can say that the measure of angle DBA equals the measure of angle 1 plus the measure of angle 2. What makes you think you can take angle 3 and just swap it out with angle 1? How can you do that? Well, if you recall, the substitution property of equality says I can do that. If two things equal each other, then I can use them interchangeably, and it doesn't matter. If x equals 5, then anywhere I have an x, I can put a 5 in it. We've been doing that in algebra for a good long time. Okay, so what can I do with this? That's DBA. I do need something to do with EBC, right? Because we want to get these two equal. Well, let's take a look at EBC. EBC, right there. And, oh, hey, look, that's angle 1 and angle 2 put together. So let's say that. The measure of angle 1 plus the measure of angle 2 equals the measure of angle EBC. How do you know? Well, the same way I knew this. Right? Angle addition postulate. That's how I know. Okay, so that's fine. But what can I do with that? What does that mean? Well, I don't know. Let's take a look. We got measure of angle 1 plus measure of angle 2 is in both of these, right? So if the measure of angle DBA equals measure of angle 1 plus measure of angle 2, and the measure of angle 1 plus measure of angle 2 equals the measure of angle EBC, well, doesn't that mean that DBA equals EBC? Yes, it does. How? How do you know? What says so? Well, that's the transitive property of equality. And we talked about that in the last video. That if we have two things that equal a third thing, those first two things must equal each other. So since both measure of EBC and the measure of DBA both equal the measure of angle 1 plus the measure of angle 2, then they must both equal each other. And that's a transitive property of equality. And here you can see that we have proven that these statements are true. All right? And so we backed it up. We can prove that this is true. It's not just taking our word for it. We've proven it. All right? So we're going to do a couple of these, but before we do, we're going to get to a couple more theorems here. Properties of segment congruence and properties of angle congruence. Okay, just to remember, a theorem is a statement that can be proven using definitions and postulates. Okay, so Notice these are the same thing, reflexive, symmetric, transitive, reflexive, symmetric, transitive, same things. So the reflexive property of segment congruence is that for any segment AB, then segment AB is congruent to segment AB, which, yeah, obviously a segment's going to be congruent to itself. You wouldn't think they need a theorem to prove that, but they do. And we'll actually use it fairly often when we get to proving triangles congruent and stuff like that. So, symmetric. If segment A is congruent to segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Notice all we did is we just changed the order of this segment congruent statement. That's it. Been doing that for a long time with math. Not a big deal. When you get 5 equals x, but you want to rewrite it because you want x to go first, x equals 5. Right? And you can do that because of the symmetric property of equality. Here we have the symmetric property of segment congruence. Same thing. And then the transitive property of segment congruence. Notice it's exactly the same as the transitive property of equality. It's just instead of being, A equals B, B equals C, it's segments. Segment AB congruent to segment CD. Segment CD is congruent to segment EF. So segment AB is congruent to segment EF. We have two things congruent to a third segment, so those first two segments must be congruent to each other. All right. And then we have the exact same things here for angles. All right. Work exactly the way, it's just exactly the same way, except we have angles instead of segments. That's it. All right. So here what we have is a summary of two-column proofs, how they work. All right. You start off with some information that you're given. A lot of times with geometric proofs, you'll also have a picture right there. If not, you'll have some information. You may have to draw your own picture. But you start off with some information that's given. Where do you start? And they're going to give you something to prove. Where do you end up? So you got a starting point, you got an ending point. You got to figure out how to get from here to there. And what we're doing here is proving the symmetric property of angle congruence. Okay. We're going to do this in a two-column proof. So we have two columns here. One column for statements, one column for reasons. Notice our first statement is always going to be our given statement. Okay. I know this is true. How do you know? Because I was given this statement. After that, you're going to have some number of other statements. Okay. Now, each of these, you're going to have some kind of definition, postulate, or theorem to back it up. To say that, yes, I can do this because this definition says I can do this. I can say this because I've got this property of equality that says I can do this. Okay. And these are things based on facts. There's always deductive reasoning. Okay, and how many numbers of statements you have is going to depend on on how complicated your proof is. Each proof is going to have a different number. So, all right, this last statement down here is going to be what you were trying to prove. Okay, because you start here and you're going to work down and work down and work down until you end up with this. However, notice that the word prove never shows up inside your proof. Okay, you're never going to use the word proof in your proof. If you do, it's wrong. Okay, that's like saying, why is the sky blue? Because it's blue. I have proven it because I have said so. Yeah, no, that doesn't work. You have to have some kind of definitions over here. The only thing that doesn't get a definition or a theorem or postulate is this first given statement. Okay. And it's got numbers here, and numbers are great. You need to number them. Something I also like to do is I like to put lines in between them, because otherwise, especially if I'm working on paper, I'm going to get all from my paper. It's going to go all crooked, and that's going to look awful and terrible. So we don't want to do that. So I would recommend putting lines in between these. Right. So what I want to do here on number 3 and 4 is I just want you to name the property that is illustrated in this statement. Okay, those properties that we talked about a minute ago. Just which one is being illustrated here. So pause the video, answer the questions, then come back. Okay, so you've paused it, you've come back, and we have this one. So we have angle RST equals congruent to angle TSU. Angle TSU is congruent to angle VWX. So angle TRS is congruent to angle VWX. How do we know which one of those statements was it? Well, I've got two things congruent to a third, so they must be congruent to each other. That is the transitive property of angle congruence. Angle congruence because they're angles. All right, and they're congruent. So our next one, segment GH congruent to segment JK. Segment JK must be congruent to segment GH. How do you know this? This is the symmetric property, not to be confused with reflexive. So probably some of you did that. All right, reflexive, remember they are both the same on both sides, right? My hand is congruent to my hand. It's the same on both sides. This one, it changes the order around. Okay, is what's happening here. Okay, so what we're going to do is do this two-column proof here. We are given that M is our midpoint. We want to prove that segment MT equals segment RS plus segment SM. I would like you to pause the video and see if you can do this on your own and then come back. All right, so you're back. Welcome. How do we start? We'll start by writing a T-chart with statements and reasons. But first statement is what we're given. We are given that M is the midpoint. How do you know that M is the midpoint? Because I was given that M is the midpoint. That's how I know. From this, what can we conclude? Midpoint, midpoint. What do I know about midpoints? Well, I do know what the definition of a midpoint is. The definition of a midpoint is that it divides a segment into two congruent segments. So I can say that I now have two congruent segments. Segment RM is congruent to segment MT. Okay, so that might be useful. I did want to talk about segment MT, so I've got something about that, right? Okay, so what else can we conclude from this? Well, I do know that segment RM is these two smaller segments added up, right? So the length of RM is the length of RS plus the length of SM. I can say that. How do you know? Back it up. Prove it. Well, I can prove that. That's simple enough. That's the segment addition postulate. Well, like that angle addition postulate we used in the first example, right? So yeah, that's good. Okay, so what else do you know? Well, I know that the measure of MT, segment MT is congruent to segment RM. Okay, how do you know that? Well, you notice from statement 2 here, which is why we number our statements, so I can go back to statement number 2. Statement 2 here says that segment RM is congruent to segment MT, and all I'm doing is changing the order. Well, why did you do that? Well, because I want the MT to go first right here. Well, how do you know you can do that? Well, I can do that because the symmetric property says so. Symmetric property of segment congruence. There we go. Okay, great. What can you do with that? Well, let's see here. I want the segment RS plus segment SM equals segment MT, right? That's what I'm trying to get to. Well, I've already said that segment RM plus segment SM is segment RM. Segment RS, right? Equals segment RM. So, what do I know? I know that MT is congruent to RM. Hey, I've got two things here congruent to a third. Actually, or I've got RM congruent to that. Either way. And so, I can say that MT equals the measure of RS plus the measure of SM. Because I've got that right here, right? I can do this with the substitution property. I can take this RM out and put this RS plus SM in. I can take this out, put that in, because they equal each other. I said so in section 3, or statement 3. And so that gets me to what I wanted to prove. Notice at no point did the word prove show up in my proof. Okay, that's very, very important. If you do that, then your teacher will count you wrong, no matter who your teacher is, and you will deserve it. So don't do that. Each thing needs to be backed up with a definition, a postulate, some kind of property, or a theorem, or something like that. And that is how proofs work. Start with what you know, use theorems and definitions to back up what you want to conclude from what you know. Right? And that's it. And I will see you next time.